Welcome back. We'll keep going. There's Bunny. Doggy hiding behind. Toy Story 4 if you haven't seen it yet. The Indian Australian tectonic plate is moving. So, tectonic plate map. Oh, this guy right here. Sorry if the wobbly camera is frustrating. I'm sure it is. What do we want? Where's the Indian Australian plate moving? So we got that plate right here. And we'll have to go through our choices. Away from the Philippine plates. I don't know if I like that. It doesn't look right to me. Away from the Fiji plates. Fiji plate, Fiji plates. Where are you? Right here. I'm not liking that either. These things are, I mean, the arrows show you, or the symbol shows you that that's convergent. That means coming together. So I'm not really liking that. Choice 3, toward the Pacific plates. I do kind of like that one. Those two coming together. Or toward the Antarctic plate is a no. Those are actually going away from each other. That is a divergent plate boundary. So I'm liking choice 3. Toward the Pacific plates. The inferred temperature. So this is a pretty simple, straightforward question. And again, I don't want to, like, it's a beautiful day outside. It's supposed to be nice. I know this online learning stuff is very frustrating. I'll try to keep the questions like as simple as I can, like this. The inferred temperature, the interface between the stiffer mantle and the astenosphere. So all we gotta do is find that. Stiffer mantle, astenosphere. There's the boundary between them. And all they want is the temperature. So we take that spot, go down to here. The pressure is about that, but that's not this question. The temperature, that line right there, intersects right there. I come over here and I see what the temperature is. It's looking somewhere between 2,000 and 3,000. So I'm liking choice 2. All right, I'll really try to make the test like heavy towards those things. There's a couple doozies in this one. I don't really worry about making these too hard for you because it's just practice, but and it's good to push yourself in practice, right? Sorry, I'm babbling. The block diagram below shows the boundary between two tectonic plates. All right. If you did the quiz that was due, what, Monday? Hopefully you got these down. And if you want me to reset that and try again, one of you just, I won't say your name on the internet, but one of you just submitted it. Thank you. Initials are BB. So if you just finished that quiz there, BB, you have to recognize what type of boundary this is. And this is going to be where this is subducting. This is where these are coming together. Oceanic to continental. If we go back to our thing, that's going to be what's going on right here. Oceanic to continental convergence. And they didn't even make you do oceanic to continental. They just said, hey, recognize that as convergent. I'll probably throw one or two of those on there. There's another one. Between which two lithospheric plates could this be found? So, yeah, and they even, I mean, like, if you ever take geology in college, this is the just absolutely perfect textbook example of that type of boundary. Oceanic to continental convergence with a subduction zone and a volcanic mountain chain in the Andes. So I'm liking choice 2. No, I'm not. I'm liking choice 3. Nazca plate and South American plate. We have a little tiny one here in the States. Right there. In fact, that, I mean, it's little, that plate, but it subducts underneath North America, and it can give you some volcanoes up through here, the Cascade Range. And Mount St. Helens went off about 40 years ago. In fact, I have some of that ash, but it's out in the garage. I won't make you chase me out to the garage, but that went off about 40 years ago, and that's a result of subduction of that tiny little plate underneath that. So, yeah. Compared to continental crust, the oceanic crust is. Now, it's an important idea. You're going to want to have it down, but you don't have to memorize it. It's sitting right here in the reference tables. Continental crust, density is that. Oceanic crust, density is that. So oceanic crust is more dense. I guess they did make us do the thicker, thinner thing, but they also gave you that in this diagram. That crust, oceanic crust, is thin. That crust, continental crust, is thick. And remember, that's the whole idea of isostatic balance. So I'm going to go, the oceanic crust should be thinner. It's the top two, and more dense, choice 3. Don't forget that's there. That'll probably show up. The temperature of the astenosphere at the depth where melting first occurs is inferred to be approximately what? So that's just to use in the diagram question. That's not necessarily in this reference table. Definitely not something you have to memorize. That's this region's asking if you can like gather information off of a chart. That's one of our standards. So if it says melting there and it says 200 kilometers about there, I'm kind of liking it. Oh, I see. And then they're going to bust our chops. What the temperature of the asthenosphere? So they're you do have to go to the table now. We're at about 200 kilometers, and we're over here at about 200 kilometers. If man, it's tight here. Come up to there. I'm thinking. Something's fishy here. I'm not liking any of those choices. The temperature of the asthenosphere at the depth when melting first occurs. 200 kilometers. Am I just not going? I guess I'm just not going far over enough. 200 kilometers, yeah, I'll buy it. That's 0, that's 1,000, so 200 is about a fifth of the way across. So a little bit above 1,000. I just wasn't going over far enough. So 1,300 degrees looks about right. Point X is located in which Earth's layer? So it tells you here that this, I'm not going to look at the answers yet, but this is continental lithosphere. I doubt the answer is going to be lithosphere. But we got to remember that lithosphere is made up, not remember, just remember to look here. Lithosphere is made up of both crust and rigid mantle. They already told us that this was crust, so I'm hoping the answer for X is rigid mantle. And it is. Number 1. Do we got more? Alright, my computer is freaking out. Let's do a video part 3. I gotta go find another Toy Story guy. I'll come back for part 3. See you in a minute. Welcome to Science.